Hi, good morning. We will start advanced SQL. In this session, we will be discussing about all the tables that we have in SQL. What are the different types of tables and what is the importance of those tables and how to create them, all these tables. See, if we see the list, we have regular table or normal table, heap table or heap organized table, GTT, global temporary table. It has two types, transaction level and session level, external table, IoT, index organized table, partitioned table, clustered table, hash table, object table, PL SQL table, nested table, compressed table, virtual table, which is table with virtual column, and materialized view. We do have view and synonym also, similar to the structure of tables. Those things we are not covering here. See, even in materialized view, the data will be stored inside it. So these are the sum of most of the tables we are covering in this session. All the types of tables we are covering at higher level. We will go in depth about some of the topics here which we have not covered in our basic SQL sessions, which is GTT, global temporary table, external table, index organized table, partitioned table, clustered table, compressed table, virtual table, and materialized view. These topics we will cover in depth as a separate topic, each of them. Each will be a separate topic. In this session, we will cover only the high level, what is minimum things required to create them, how to create them. Up to that level, we will be discussing in this session on all these things. But the topics which we have told now, all those things we will be covering as a separate topic, each of them in detail later on. Let us start with the tables now. The first one is the regular table, the normal table. This we are already familiar with this thing. See, the minimum requirement for understanding the advanced topics is the basic SQL. Since we are covering advanced SQL now, this is advanced SQL, the minimum requirement to understand these topics will be the basic SQL. If we are good in basic SQL, then we can understand these topics very well. I will try to cover as much simple as possible so that even the beginners can understand, even if it is advanced level. The normal table or the regular table. So I will not be going through in detail about this because this is very basic table. T normal, this is how we create the table. Table is created. This is logical table. This is not the physical table. It is just logical structure of the table. The table will store data inside it. When we describe the table, it looks like this. We can insert data into that. We have committed. When we select data, it will show. We have inserted 4 records, so 4 rows selected. So we can perform all the DML operations, that is read operations and write operations on the regular table. We can alter or modify the structure of the object. So almost all the alterations are possible on the regular table. We do not have any restrictions here. But we do have some restrictions when we have data in the table. But when we don't have any data in the table, any modification is possible. When we have data in the table, the limitations like reducing the size of the column may not be possible beyond the maximum size of the data. Such type of restrictions will be there. But when there is no data in the table, all the modifications are possible. Second one, heap table or heap organized table. This is same as our regular table, but still we have an option. At the end of the table, we see organization heap. The structure looks like our normal table, nothing special here. Only the additional clause will be present at the end, that is between closing bracket and semicolon. Organization heap, table created. When we describe, looks like normal table. Like normal table we can insert, like normal table we can select. Update is allowed, we have updated. After select, if you see employee number 4, the department number is updated to 40, before it was 30. We have updated. Delete, yes, employee number 4 is deleted, it became 3. Rollback is possible. So we can insert, update, delete, select, merge. We can perform all the operations on heap table or heap organized table. The structure can also be modified, but DDL operations we are not covering here, but all the alterations are possible to the heap organized table or heap table. Next, global temporary table. GTT stands for Global Temporary Table. The name indicates temporary table. The structure is not temporary here, structure is permanent. Permanently will be stored in the database, that is the structure of GTT will be stored permanently in the database, but the data is temporary. Data will be stored temporarily in the database. How long the data will be stored in the GTT? That decides based on the additional clause we specify at the end. On commit delete rows. We have another option, on commit preserve rows. That means after commit, whether we want to preserve rows or delete rows. So if it is deleting, then the GTT becomes transaction level, means the data will be available till the end of the transaction in the GTT. Once the transaction is completed, that is after commit or after rollback, the data will be removed from the GTT automatically. We need not perform a delete to remove the data from the GTT. This is the advantage of having GTTs. And on commit preserve rows. After commit, data will be preserved, data will be present in the database, but this data will be present till the end of the session only. So this is session level GTT. The data will be available throughout the session. But one more advantage of GTT is the data whatever we have stored is available for that session only. If any other user has stored data in the same GTT, that will be available only for his session. So since there are two sessions simultaneously running, both the users can store data in the same GTT. Since it is session level, so data will be stored in their own sessions respectively. The session 1 can store 100 records, session 2 can store 200 records. Totally there are 300 records in the GTT, but when we access from session 1, it will show only 100. When we access from session 2, it will show only 200. If we access the table from session 3, it will show 0 because we have not loaded anything. We have to insert the data into GTT. Once data is inserted, then we can perform all the operations: insert, update, delete, select, but as long as the data is available. Now let us see practically how it works. We specify create global temporary table. Instead of create table, we specify global temporary table. This indicates that we are going to create a temporary table in the database. We have to physically create before using that. At the end, we specify on commit, preserve rows or delete rows. Two options. Here we specified delete rows. That means this is transaction level. GTT is transaction level. Once we commit, data will be removed from the GTT. Till the commit, data will be available. That means till the end of the transaction, data will be available. Once the transaction is completed, because of commit, data will be removed from the GTT. We can describe, no restriction, like normal table it is described. We can select, we don't have any data. We are inserting now. 5 records we have inserted. After insert, we have selected 5 rows selected. If we commit, transaction will be completed, data will be removed. See, no rows selected. Data is removed. So till the commit, data will be available. After that, we can, before that means before commit, we can perform any operation on that as long as the data is available. Now let us see the session level. Here we will add the additional clause at the end, like on commit, preserve rows. We are connected through SH schema, creating global temporary table, GTT session. At the end, on commit, preserve rows. After commit also preserve the rows, but this rows or this data will be preserved till the end of the session only. Describe the GTT. Select star from GTT, there is no data. We have inserted 5 records. When we select, 5 records are displayed. Now commit. Even after commit, data will be available here because it is session level GTT. Now rollback. Rollback is completed. Still the data is available because we have committed here, so it cannot roll back. Now we connect to HR, another schema. Select star from GTT, no rows selected. We connected to HR, means the session is closed. We came back to SH again. Now we select, there is no data. That means once the session is over, the data will be lost. Because we connected to HR from SH, the SH session is closed, HR is opened. Again we come back to SH, HR session is closed, SH new session is opened. So in the new session, table is there, but there is no data. Now exit, closed. Again we connected to SH. Select star from GTT, no data. We wanted to add primary key on the GTT. Yes, primary key can be created. Constraints can be created on GTT, whether it is transaction level or session level. There is no restriction because the structure of the table will be stored in the database. So we can add the constraints. We can add index, allowed. Indexes can be created on GTTs. Constraints can be created. Even the primary key can be created. Create synonym for the GTT. Yes, allowed. Create view based on GTT. Allowed. all the operations we are trying. Alter GTT, we are altering, modify the data type, modify size, increase the size, decrease the size, drop column, hide column, rename column, add. Most of the operations are possible. We don't have any restriction. Now let us see the global temporary table, the session level table with two sessions simultaneously side by side. One session is SH, another session is HR. We describe GTT in SH, it is there. In HR, we don't have it because we have not given the grant. Now, grant, select, insert, update, delete on GTT to HR. Grant succeeded. After that, if you describe sh.gtt, it is there from HR. Left side is SH schema, right side is HR schema. Okay. Now, select star from GTT, there is no data. Select star from SH dot GTT, there is no data. Now, we are inserting in both the sessions we are inserting. Let us see the difference. Here we are using 1, 2, 3, 4, 5. But here we are using 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Other columns are same. Only the first column is different. Session 1 is having 1, 2, 3. Other one is having 11, 22, 33 like that. Now, from SH when we select, it is showing 1, 2, 3, 4, 5. Only 5 rows. From HR when we select, it is showing 1, 1, 2, 2, 3, 3, 5 rows. Means the data is different. Even though we are inserting into the same table, since it is session specific table, the data will be displayed differently. Data will be stored in their own sessions, not into the database. That is why, since it is session specific, whatever the data we have inserted into the GTT can only be visible for us. Others' data cannot be visible for us. But any number of users can store the data into GTT at the same time. See, we are running two parallel sessions. We are inserting this side, we are inserting on the other side. But whatever we have inserted is visible here. Whatever is inserted in the second session is visible to that session only. If you take the count, only 5, not 10. Now, connect to SH. New session is started. Select star from GTT. There is no data. Once we connect to, even though we are connecting to the same schema, but old session is completed and a new session is started. That is why there is no data. But we are continuing in the other session, HR. If we select after this, still it has data. This session is closed, so there is no data here, but the other session is not closed, still data is available over there. If you close that session, connecting to HR again, old session is closed, new session is started. So after that, if you select, there is no data. This is how the global temporary table will work. It need not be session specific, it can be transaction level also. In the same transaction, data can be available for multiple users. Multiple users can store the data into the transaction level GTT also. Next table is external table. This is a bigger topic which we will be discussing all the possibilities in detail separately in the external table topic, but here we will see how to create external table. See, it's like normal table. At the end we specify organization external. Normally external table does not store any data in the database. Only the structure will be stored in the database. Data will not be stored in the external table. Data will be stored in the operating system, that is outside the database, in the form of files. It can be a CSV file, Excel file, text file, any kind of file. The actual data will be residing in the file. Only the structure will be stored in the database, but when we select data from the external table, it will actually read the data from the external file and then it will display to us. So when it is reading from the external files, it will be using Oracle loader like SQL loader. So we have SQL loader. Similar to that, we have Oracle loader. External table is introduced in Oracle 9i. Before that, we do not have that. So starting from Oracle 9i, Oracle loader is also introduced. Oracle loader is used in external tables for loading or reading of data from external files to the database table, into external table. So Oracle loader is a small utility like SQL loader. SQL loader has lot of options, multiple options, but Oracle loader has limited options. The basic operations what we require for loading is available in Oracle loader. So SQL loader requires control file. Similarly, Oracle loader doesn't require any control file, but those control file features, the content will be added at the end of the external table while creating the table. See here, if you see here, after organization external, we specify some additional parameters. Default directory name. So where the actual file is residing, to that folder we should have access through the Oracle directory. Directory is also a separate topic. We will discuss in detail in that topic. As of now, it is the path, or this is Oracle directory with the path where we are storing the files. In the same path, the file should be present. Next, access parameters. How the records are delimited and how the records are terminated or fields are terminated. How the records are delimited or terminated and how the fields are delimited or separated or terminated. And then the location of the location. The location means not the path, the actual file name. The actual path will be available in the directory when we have created a directory, and this location will have the file name. We can read data from single file or multiple files also. So these are the some of the basic parameters we require for Oracle loader, and there will be some additional parameters. Skip, if the file has any headings, those headings we don't require while loading the data, so we need to skip them. If there is any error, if any record has error, then we need to reject. So all those parameters are available while loading the data into external table through Oracle loader. We can specify all of them. So all those options we will discuss in our external table topic. So this is simplest form, table is created. So we can identify the external table with this clause, organization external. So that external keyword indicates that this is an external table. So external table does not store any data in the database. The actual data will be stored in the form of file. Whenever we select data from the external file, it will load the data from the file and then it will display. We can use all the DML operations, DDL operations, alterations are also allowed. Next, IoT, index organized table. Like external table, this also will have additional clause, organization index. This indicates The table is index organized table. To create an index organized table, a primary key is mandatory in that table. Compulsory, we have to create primary key constraint on any of the columns. There is one difference between index organized table and all other tables in the Oracle database. In all other cases, the data will be stored in the data segment, but in case of IoT, index organized table, data will be stored only in the index segment, not in the data segment. There will not be any data in the data segment. Data will be present only in the index segment. But in other cases, if the data is present in the table, data will be stored in the data segment. But in case of external table, there is no data, so there will not be anything in the either data segment or index segment. In case of GTT, it does not store any data in the database. It will store data only in the memory. So no data will be present in the data segment, only in the buffer or memory. Similarly, when it comes to the IoT, index organized table, data will be stored only in the index segment. No data will be stored in the data segment. See, table is created. Again, it is a separate topic. It's a lengthy topic. We will discuss all the possibilities in detail about index organized table in the separate topic. Here I am showing what are the different types of tables are there, how to create them at simplest format, higher level, and brief introduction of each table. Next, partitioned table. Partitioned tables are introduced in Oracle 8 with one partition. Oracle 8i added one more partition, 9i added another partition, 10g they have added composite partitions or sub partitions, and in 11g they added many more partitions and even automated partitions. So when we say partitioned table, a single table is divided into multiple partitions, and each partition will be acting as a separate table for the user at higher level. So we can treat each partition as a separate table. On each partition we can perform a select, insert, update, delete, truncate, drop, etc. Means we can drop the partition, we can truncate a partition, we can delete from the partition, we can update only in that particular partition. That means each partition will be acting as a separate table for us. The partitioned table have their own indexes, global and local. Local index can be created only on partitioned table. Other tables we cannot create local indexes. Means each partition will have a separate index when we create local index on a partitioned table. So one table will be divided into multiple partitions. The type of partition we can choose. We have many types of partitions like range partition, list partition, hash partition, interval partition, virtual column partition, reference partition, system partition, etc. Again, partitioned table is a bigger topic, so we will discuss all the features, all the types of partitions, different types of partitions, what is possible, what is not possible, how to select from a separate partition. All those things we discuss in a separate topic as partitioned table. Here we will see how to create a partitioned table. So what is partitioned table is when the data is huge in a bigger table, instead of storing the entire data as one table, we create a partitioned table and we divide the data into multiple partitions. When we have data for 10 years, we can divide the table into based on the year. Each year's data we can put it into one partition. Here we are creating partitioned table based on range partition, and this range partition we are creating based on number column. See, up to here it is table. We don't specify create partitioned table like that. We just say create table, table name. Till the closing bracket it is same. At the end we specify partition by. This indicates it is a partitioned table. Here we can specify the type of partition. Here we have chosen range partition on a number column, employee number. Next we are specifying the number of partitions. Here we are creating 3 partitions, partition P1, partition P2, partition P3, and in each partition we need to specify a limit. Since it is range partition, we need to specify values less than 10. If we insert any value into the table which is less than 10, means up to 9, 1 to 9, 0, all the negative values including decimals, fractional numbers, all those things will go into first partition. Second one, values less than 20. If we insert the value which is less than 20, that is up to 19, and it should be more than 10, 10 to 19, it will go to second partition. If we insert a value 5, this is eligible for first partition, also eligible for second partition. That means it will not insert in both the partitions. First it will check first partition, if it is eligible it will insert and stop. If you take 11, it is not possible to insert into first partition, so it will go ahead and check in the second partition, then it will insert here. If you take 25, first partition not eligible, second partition not eligible, third partition it is eligible, it will store. If you take the value 31, it is not eligible in any of the partitions, it will be rejected. Even 30 will be rejected because it is not values less than or equal to, values less than. So up to 29 only we can insert values into this table. So if you want to insert 30 or above, we need to go for some default partition. Those things we see later. So this is how we create partitioned table. Table is created. Next, clustered table. Another type of table, clustered table. This is also introduced. The cluster concept is introduced in 9i and further enhanced in 10g. From 10g it is widely used, first introduced in 9i. So when we say clustered table, what is cluster? Cluster is nothing but